So let's start with the next exercise, that is principal component analysis, and this is done with the help of the breast cancer data, where again we are going to decide whether the cancer is benign or malignant, right? So the data set is again used, we already used it. Now the same data set is being used here again. So we have to find out the breast cancer, that means breast cancer detection, and the libraries, the libraries that we want are again the same: pandas, numpy, matplotlib. So we can run all this. Before that, let me clear all this output, so we can clear that so that everything can be fresh. So you can run this. Of course, this is just a remark. Again, the libraries are to be imported. Then from sklearn dataset, we know that this breast cancer dataset is available in the sklearn, so we can import it from there. Run this. Then cancer, this is of course a variable here, but on this we are going to transfer the data. So cancer is equal to load breast cancer, right? Type is cancer. So again you can get other details like utils, bunch, etc. in sklearn. Then cancer data, you can again run it. See that it is a numpy n-dimensional array, right? So then we want to know the type, or rather shape of the data. So again that we can get with the help of this, which means that 569 rows and 30 columns, right? This is the total structure of the data. Then cancer data, first 5 rows can be seen like this. This is because it is an array, so you are seeing an array of data, which is all the data elements. Then cancer data targets are that you can again find out with the help of this, that is 0, 1. Either it will be 0 or 1, that is either it is a benign or it is malignant. So that is how it is. This is our target, right? So we can go further down and see that what are the keys in this. So keys are, cancer.keys are data, target names, description, feature name, file name, right? Then we can also print the description of the cancer, and this is available as a part of the data set itself. So you can run it and you will get all these details here, like which I think we have seen earlier also. So this is the type of data that you have got, giving complete details about the data set. Like here you can see that this is breast cancer Wisconsin diagnostic dataset. Dataset characteristic, number of instances is 569, that is rows, and number of attributes are 30, which are again the number of columns, so to say. Then attribute information, these are the various attributes which are there. Then the mean, standard error, worst, largest, etc. All the details are there. Now, well, all of them are not relevant for us, but definitely it is available. So, and then WDBC is malignant and WBC is benign. So either of the two will be there. That is the case. And these are the summary statistics. The mean, then of different variables, different features, concavity, mean, smoothness, mean. So all the such information is available, and if required, one can use it. Then comes the data in array can be converted in columnar data with following code. So we can again convert it like this, and which we can see also here, like here. So we can print the 5 top records which are available here. Like again, all the variables will be available to you, and the top 5 rows which are available here. So 5 rows and 30 columns. Then we are going to use standard scaler, assumes that the data is normally distributed within each feature and will scale them such that the distribution is not centered around 0 with a standard deviation of 1. So we can run this. This again is a remark column. Then we are going to import the standard scaler, because we are going to use the standard scaler. This again is a library available with sklearn and under pre-processing. So we can import that also. So after importing, you can see that it has come here. Then we are going to run again for a scaler is equal to standard scaler. That also can be done with this. Simple commands, very simple. Only thing that we have to practice, we have to remember, and we can always understand that where we need what. That is important. Then again we are going to have a scale data is equal to scalar transform df is the data frame. Then scaled data, and so scale the data, then again you get an array, because now you have scaled it by using this scaled standard scaler. So once you did this, that means the data gets further scaled, and that is why there is some change in that. So this again comes in an array because we have used array for that, right? So now we need to decompose the data. So for that we need to import PCA. Now we are importing the PCA, that is our objective. PCA means this principal component analysis. So we can run that from sklearn decomposition import PCA. So we can import from this sklearn itself under the decomposition. So this again is sub library of that. By importing this we can have it here, and then PCA is equal to PCA n components is equal to 2. The number of components that we want is 2, because it is either benign or it is malignant. So that is why only 2 components are there. That is what our objective is. So that also has been done. The PCA fit scale data. Now we are going to fit it. So you can see that PCA copy true, iterated, power auto, n components, number of components 2, random state none, SVD solver auto, tall is 0, whiten false. So of course this is nothing, this is just for our information. XPCA, PCA transform scale data. So we are going to scale it further, and then scaled data shape. What is the shape now after scaling? So again we are having the same number of rows and columns, that is 569 and 30. So now we are going to check for the PCA part of this. Again in PCA, number of rows, and the 2 is the number of say types of whether it is malignant or benign. So that is why the 2 has come here, shape of that, right? And then this scaled data, we can see that here again in the form of array that has come, right? And then XPCA, this again comes in the form of an array. Yeah? So these are all for our information, and of course because here it is showing that yes, what is the type of action that you have taken. So what is that we have to find, and now we are going to check the graph that will tell us that how many data points are there, or how many people out of the whole lot are having the benign cancer and how many are having malignant. So here you can see that a PLT figure, fixed size 5.3, scatter plot we are going to have. XPCA is going to be used here. This is the function of, because this XPCA is going to be printed. So these are actually the data points which have been created, and with the help of this we are creating the scatter plot. So scatter plot with XPCA 0, XPCA 1, this is again 2 benign and malignant, and cancer is the target is that. So X level we are having first principal component, and Y level we are having the second principal component, and when we run it you can see we are getting a scatter plot giving the first principal component and the second principal component. So this side it is the first principal. Now first, if we have assumed, if we have taken as the benign, it will be this, and second will be the malignant. So that is how we can segregate our data between the benign and the malignant cancer for the breast cancer, right? So this completes our breast cancer detection with the help of the principal component analysis. Thank you.